Hello and welcome to GPB's live exploration, Georgia Electricity. We are live in Hiram at the incredible Greystone Power Corporation, where we will be exploring the power of electricity. I'm your host, Ashley Mingwasser. Throughout today's show, electricity experts will be available to answer your questions live. Submit your questions by sending us an email at education@gpb.org, or for the first time ever, you can go to GPB Education's Insta story to send us your question. During the show, we're also going to be asking you a few questions, so charge those devices because here's your first pop quiz. Which of the following is a good conductor of electricity? Is it 1, glass, 2, paper, 3, diamonds, or 4, salt water? You only need to choose one of the following ways to vote. Just go to gpb.org/electricity and select your answer there, or use a cell phone and text 1, 2, 3, or 4 to submit your vote to the phone number 430-206-3151. Now that you're plugged in, let's take a deeper look at what electricity actually is.
I'm Andy Paul. I'm the Public Relations Representative for Georgia EMC. So we are representing the 41 electric membership cooperatives across our state. And so our job is to provide safe, reliable, and affordable power to rural areas and urban areas all across the state of Georgia. We're here at the Electric Cooperative Training Center, which has this training substation, which allows our line workers and linemen to learn about all of the different safety aspects when it comes to dealing with electricity. Electricity is a form of energy resulting from the flow of electrons. Electrons are negatively charged particles that are found in atoms. You can think of atoms as the building blocks of matter, and they are found in everything. Electricity happens when electrons get bumped from one atom to another. We encounter electricity constantly. Electricity exists naturally, even in our own bodies, and it can be harnessed and generated for everyday use. There are two types of electricity: static electricity and current electricity. Static electricity is caused by friction when two items or things rub up against each other and creates the potential for a discharge of electron. Now, this can happen on a really cold morning when we're walking across the carpet and creating that friction, or it can be as huge as two clouds colliding together to create lightning. In 1832, a man named Michael Faraday discovered that electrical charges could be made when an electrical conductor was moved in a magnetic field. This movement resulted in an electrical current. This discovery allowed us to take the electricity that we knew was there, but allowed us to harness it. We're able to create electricity in a lot of different areas and generate that energy through different examples of traditional resources like natural gas, coal, and even nuclear energy. There's also renewable resources like solar and wind power. Now, how that different? Static electricity is like a giant buildup, and so this energy is being stored and prepared for one big release. And that's not what we're wanting in our homes. We don't want our homes to have one giant release of electricity and our lights to cut off. That's why we have to use traditional generation methods so that we can have the lights glowing until we decide to cut them off. The heart of the power plant are these turbines. These turbines rotate giant coils of wire between these two magnets, which generates what engineers call electromagnetic induction, which creates electricity. You'll see the same basic elements no matter what power generation plant you go to. Conductors are what allow us to send electricity from our generation plants to our homes. So we have to have a high quality conductor to get that electricity. But a conductor is a material that's really good at transmitting electrons. So we think about metal, copper. An insulator is a material that is not good at conducting electrons. Rubber and glass are two examples examples of these, which is why when you see linemen working around your house, they have on these giant rubber gloves to make sure that they can remain safe as they're delivering electricity to your home. When electricity is generated, it's transported across these giant electrical lines, these giant wire structures that you're probably seeing as you're driving down the road, in the tens of hundreds of thousands of volts. And then it travels to a substation where it can be brought to typically less than 10,000 volts. From that substation, that's where the power is directed to the transformers right outside of your home and then into your home that power your appliances. So that same electricity that starts at the power plant is the same electricity that powers your home. Electricity from a power plant is fed into the electric grid, which is a series of wires and connectors that make up this giant entire circuit, which brings power to your homes. The word circuit comes from the word circle, which means that the electrons have to flow in a complete circle all the way back to the source. And so we add outlets, motors, and switches along that circuit so that we can harness the energy. Now we can also use switches to create a smaller circuit within there so we can use that energy in our homes. Those switches allow us to cut on lamps and other electrical appliances. And when you see those everyday appliances like a lamp, you'll notice that it has a paired wire with prongs that allows the electrons to flow in one complete circuit. So when we turn a switch off, we're disconnecting that circuit, which is why the lights cut off. We are completing that circle when we turn a switch on. Life without electricity would look a whole lot different. Electricity provides convenience when it comes to heating up our food, heating our homes, or providing us with entertainment. I can't think of anybody that wants to sit at their dinner table powered by an oil lamp doing their homework. But electricity allows us the convenience for everyday life and provides an opportunity for safe and thriving communities.
Wow. And here to bring us more light bulb moments like that about electricity is Maggie Reenstra with Coweta Fayette EMC. Welcome, Maggie.
Thank you for having me.
I'm so glad you're here. We have heard this acronym EMC mentioned a few times today so far. Tell us, what is an EMC?
Okay. An EMC is an electric membership cooperative, and we are one of the companies that brings power to homes. We cover about 73% of the landmass of Georgia and about 43% of the population.
Almost 3/4 of the state. Very cool. Well, Maggie, I think it's time to answer our first pop quiz question, if you'll help me out. Here's what it was. Which of the following is a good conductor of electricity? And here's how our audience voted. Take a look there. Okay, a lot of answers for D, salt water. Maggie, what is the right answer?
The right answer is salt water.
They nailed it.
They did, and that's because salt has electrically charged particles in it called ions, and those ions move around freely in water and help the charge to pass through and complete the circuit.
Very interesting. And I understand you have a little demonstration here with all these components to show us just how salt water is a good conductor.
Absolutely.
Take us through that.
All right, so everything you need: a light, 2 iron nails, wires, and a battery source, and salt. And for safety, I always use a switch. So right now, our nails are in the water, and when I close the circuit,
nothing is happening.
And that's because plain water isn't conductive.
Okay.
But watch what happens when I add the salt.
Okay, so now the circuit's complete. We're adding the salt. Oh, look at that. Wow, that light bulb lit right up.
Yes.
Amazing.
Yes. And so our ions are floating around in the water, transferring the electrons between the nails and completing the circuit.
Okay, our circle is open. We had all of the items in place, and salt water served as our conductor. So is that why we should stay out of the water during a lightning storm?
Absolutely.
I've heard that.
Yes, definitely stay out of water during a lightning storm.
Okay.
Salt water can be up to 1,000,000 times more conductive than fresh water, but all water is dangerous during a storm, so definitely stay safe.
1,000,000 times. That does sound dangerous. I will be listening to my grandmother. Students in Miss Diaz's 5th grade class at Liberty asks, if you put your finger in a light socket, why does it shock you? Those Liberty Elementary students have good questions.
Very smart.
One to stay away from.
Yeah.
Why does that happen?
The outlets in your house bring electricity into your home for your appliances, and our bodies are very good conductors. So when you touch the socket, that electricity looks for a path to travel and it's going to be into your body. So be safe around those.
We are the path.
We are.
I've been telling myself that my whole life. Fifth grade students in Midway, Georgia want to know, how do batteries serve as an energy source? Well, we've just seen that a little bit.
Yes, everybody probably knows about smaller batteries, so they're portable sources for our toys or our phones, but larger batteries can be used to store other forms of energy like solar energy so that we can use it at night when the sun is down.
Okay, and students from Mill Creek Elementary, hi Mill Creek, they want to know, what is the difference between parallel and series circuits?
Okay.
This sounds technical.
So a series circuit is this one. It makes one circle, and everything that from the power source back around is a circle. And in a parallel circuit, it's more like a ladder.
I see.
So instead of one circle, you've got multiple paths for the electricity to travel.
Very neat. And another question from our viewing audience. Ashlyn from Gwinnett County wants to know, are there any cool experiments that you can do with static electricity? I like that question because I just learned that lightning is actually static electricity.
Yes,
How can you
absolutely.
replicate that for us? I want to see.
I will. Great question, Ashlyn. I have a really easy experiment here that you can do. All you need is a balloon,
A balloon. Here comes the
piece
party.
of wool cloth, and some paper confetti. So you're going to take the wool cloth, rub it on the balloon, and what we're doing is transferring some electrons onto there
With friction.
with friction, and then when we put it near here, it's going to
Whoa.
pick up
What is going on
our
there?
confetti. So when I put the negatively charged electrons onto the balloon, the confetti is positively charged. They want to be equal, so they're attracting.
Like a magnet.
Yeah.
That is so interesting. Let's go to another iPad
Okay.
question. Would you like?
Sure.
Okay, Caleb, a sixth grader in Mrs. Hunt's class, wants to know, what are different ways that we can use electricity in the future? A visionary, this one.
I like that.
Yes.
Well, we're certainly going to switch from fossil fuels and non-renewables to renewables and cleaner forms of energy, but we're also going to be able to store it better, and we're going to be able to power bigger things because we're better able to use that power, like large farm equipment, tractors, trains, maybe even planes one day.
Okay, we're seeing that with our own automobiles, but it's interesting to think about agriculture and flying aviation. Very cool. And since we've been getting such great questions from you all, keep them coming, it's time for us to give you another question. So here is your second pop quiz. Which historical figure helped expand electricity access to rural America? The answer might surprise you. Was it 1, Benjamin Franklin, 2, Franklin Roosevelt, 3, Thomas Edison, or 4, Rosa Parks? While you ponder that, I have a bright idea. Let's take a closer look at how electricity is generated from the sun.
Right now, we are at one of Green Power's solar sites in Elko, Georgia, and this provides power to homes, schools, and businesses throughout the state. This site sits on over 700 acres and has more than 225,000 solar panels. The solar panels are going to capture sunlight and then convert that energy to electrical energy that can be used in our homes. Solar energy is energy that we get from sunlight. Sunlight is made up of particles called photons, and these photons have energy as a part of them. And so when the sunlight hits the panels, that energy is then transferred into negatively charged electrons. Those electrons are going to flow through the panel over to the inverter, which will convert the energy so that it's the type of energy used in our homes. There's lots of wires that are involved at a site like this. So you can see under some of the panels that they run underneath them, but then they do go underground, and there's trenching that goes from the panels to all of the different equipment on site. The wires carry the energy from the panel over to the inverters and transformers, and ultimately to the power lines that take it to your home. So the first thing about orientation of the solar panels is that you're going to want them to be south-facing in direct sunlight without any shading. And then there are 2 different types of racking systems that can be used. The first one is called fixed tilt. Those panels will stay at the same angle all the time throughout the day. These panels behind me are on single axis trackers. So they're gonna move throughout the day and follow the sun just like a sunflower. And they're gonna be able to produce more energy than a panel that stays at one angle all the time. When it's cloudy, we will still get some energy production at this site, but it's not going to be nearly as much as if it was a sunny, clear day. Another thing that'll impact how much energy we get is the temperature. If it's too hot, the solar panels don't like that either. So the perfect day is a day just like this, where it's sunny, it's clear, and it's a nice, moderate temperature. There are lots of different ways that solar panels can be used. This is a really large-scale site, but you can put them on the rooftops of homes and businesses to be used right there where you need the energy, or it can be used for traffic lights and other small lights that are outside. So solar panels come in all different shapes and sizes. Solar energy is on the rise, and Georgia is #7 in the nation for solar energy. And we're really excited because solar is a renewable resource and is going to have a lot of environmental benefits. Some of the benefits of solar is that the fuel is free. And so when the sun is shining, we'll be generating energy. Another great thing about solar is that it has faster construction period than other generation sources. So it can help us to meet the growing demands in the state. We can't power all of our electricity needs with just solar because the sun doesn't shine all the time. So we have lots of different types of energy that we use in the state. Most of Georgia's energy is going to come from non-renewable resources. So this is going to be nuclear, natural gas, and coal. But a piece of the puzzle is from our solar resources. It's really important that we get our energy from a variety of sources. When we have other sources of energy, then there's more reliability in our system so that when you turn that switch in your house, the lights are going to come on. Solar is growing in the state of Georgia. It's not just a trend, it's not something that's going to go away, and it's something that we're really excited to be a part of.
I'd like to thank our VIP panel for attending today. Yes, thank you for your contribution. I will never take a sunny day for granted again. Oh no. Here with me now is Tamika Lampkin, who is the Director of Cooperative Communications at Jefferson Energy Cooperative. Welcome to the show, Tamika.
Thank you. Happy to be here.
I'm so glad. I love your megawatt smile. Would you tell us a little bit about your job, please?
Sure. Well, I work in the community, so I guess you can put the C in communications with community. I work with students and educators and organizations to help teach about electricity and how to safely use it.
Safely use it. Sounds like a
Safely.
fun and important gig
Yes.
for the safety piece. Earlier, we explored a large solar field here in Georgia, but what we didn't see is how all that grass in the solar field is kept short around the equipment. Who mows those fields, Tamika?
That would be sheep. They actually graze on the grass and they help keep the grass low, and they also fertilize the land. So don't be surprised if you see them around.
A flock of sheep. I will definitely now be on the lookout for those solar sheep. Since many of these solar fields are found in rural parts of our state, I think it's time that we go on to answer our second quiz question. You with me? Let's do it. We asked our audience which historical figure helped expand electricity access to rural America, and here are those results. I see, very interesting. Tamika, who is the correct answer?
That would be President Roosevelt.
Oh, wow, people are surprised by that. It looks like a lot of them thought Thomas Edison, but I understand Roosevelt has a very unique tie to Georgia. What's his story there?
Yeah, so FDR is from New York, but he also had a home in Warm Springs, Georgia.
Warm Springs.
Yeah, and in the 1930s in the big city, electricity was common, but in rural areas like Warm Springs, not so much. So when he spent his time there, he was inspired to create the Rural Electrification Administration. And the REA was a part of his New Deal program that helped provide electricity and jobs for people in rural areas.
The REA.
Yes.
And because of the REA, you're saying those rural communities, like this would have been Greystone back in the day, they were able to gain access to electricity for the first time.
Yes.
That is pretty powerful. That history lesson really flipped a switch for me. Thank you, Tamika. It looks like we have sparked some curiosity from our audience. I love our audience. We have a question coming in from Rebecca in Columbus, Georgia. Rebecca wants to know, how do electromagnets work? This sounds complicated.
Not so much. It's a really good question. So they work like regular magnets. They stick to metal, but they can be used to flip on and off with electricity as well.
That's actually pretty simple. And you have a cool demo to show us. Is that right, Tamika?
Yeah.
Take it away.
Okay, so to make your own electromagnet, all you need is some copper wire, a nail, some electrical pliers, a battery, and some paper clips. And so, just like we said before with completing the circuit, what you would do is complete the circuit like this. Well, first,
Nothing's happening.
Nothing's happening.
It's not magnetized.
Once we complete the circuit,
We should see some attraction there.
we should.
I see some.
I see some too.
I see some.
Our
Okay, that's
battery
really
is not-
cool.
Yeah.
Sometimes our batteries fail if we've been using
Yeah.
them too long. I understand that too. Is there a way to turn off the magnetism? Might we have accidentally turned it off?
I think we turned it off. So what
Okay.
we would do is we would just disconnect one of the circuits and it'll be turned off.
Okay, so that you turn it off by disconnecting, breaking the circle, and you can turn it back on by reconnecting it. I could replicate that anytime. Thank you so much. Would you
You're
like to
welcome.
take some questions from our audience?
Sure.
Let's go to that. We have Allie, a 5th grader, chiming in from Miss Rivera's class. Can you stop electricity from happening like lightning in the sky? Can we stop that?
Well, you can't, because lightning is naturally occurring. It occurs naturally, it's weather, so we can't stop it. And because we cannot stop it, we want to make sure that we're safe around lightning.
Yes.
Because it's very strong, very powerful, and it can't be stopped.
We can't stop it.
Yeah.
Journey in Miss Holloway's class in Statesboro, Georgia, wants to know, what is the better place to put wiring, I guess electrical wires? Would it be above ground or beneath the ground?
Well, both are very important for electricity. It just all depends on the type of job that our linemen are doing. You see more above ground, it's just more common because it can be potentially dangerous to use underground wiring if you don't know what to do around it. So if you dig around it and you're doing something that you're not supposed to, you're not using 811, you might have to call 911.
Oh,
so we want
boy.
to make sure that we keep it safe.
I like that. I'll never forget that. And we can't forget that this electricity can generate heat too. So that
is
could be
true.
happening underground. Here's another one for you. Miss Bolton's class at Veterans High School asked, what is the speed of electricity?
So electricity is almost as fast as the speed of light, almost.
Really?
And because of that, we use wiring and friction to slow down electricity so that we can safely use it in our homes and schools and things of that nature.
Speed of light, that's pretty fast. Students at Murdoch Elementary in Marietta, Georgia want to know, will we ever run out of electricity? That's a good one to end on. Can we ever run out? Is this scarce?
No, it's not scarce. Electricity is all around us. We even have electricity in our bodies. That's why we're natural conductors. So no, we will not run out, but we still want to make sure that we take care of the earth and we conserve electricity.
You got it. And it's time to take out those devices because here is your final pop quiz. This electric item was first successfully developed in the U.S. in 1891. Was it 1, the electric vehicle, 2, the electric guitar, 3, the electric refrigerator, or 4, the electric blender? Some tough choices there. I don't know about you all, but I am amped up to discover more about electricity. For our final site visit, let's take a look at how manufacturing facilities have their own special requirements when it comes to power.
My name's Dan Miller. I'm a manager of site engineering here at Boehringer Ingelheim. We manufacture animal health vaccines, largely for pets, livestock, and horses. This site in Athens, Georgia, produces over 90 million vaccine doses every year. There is no way that we could manufacture vaccines without electricity. Here on site, we use electricity for almost all of our production equipment. It powers everything from large chillers and air compressors down to the computers that we all have, as well as even microscopes inside of labs. So we have a lot of different levels of cold storage, and sometimes we need to keep it that cold in order to maintain product stability. It ranges in temperature. We have large rooms that are held at 4 degrees Celsius. We also have large rooms that are at negative 40 degrees Celsius, as well as stand-up freezers that are at minus 70 Celsius, and all of these are powered by electricity. If you think about it as meat being left out at home, it would go bad. This similar process applies with our vaccines. The product would go bad if we weren't able to maintain these temperatures. So we needed to be cold in order for the vaccines to work. Here at Boehringer Ingelheim, we have an emphasis on sustainability. So we rely on renewable energy power from Jackson EMC. 100% of the power that we get here on site from Jackson EMC is powered from solar electricity.
Hi, I'm Tino Johnson with Jackson EMC. Essentially, we're the power company. I am a business development manager at Jackson EMC, and my job is to make sure that people get their power, especially our manufacturing facilities like Boehringer Ingelheim. This is a massive campus, and so when thinking about just to keep the lights on, they're using at least 20 to 30 times the amount of light bulbs that you would see in your house. Just that alone is going to be exponentially greater than what it takes to power your home. So this is a 24/7 facility that's 24 hours a day, 7 days a week, 365 days a year. The lights are always running, so this facility is never going dark. And when thinking about their power needs, this facility specifically uses about the same amount of power that it would take to power 1,300 homes or 35 schools. So we're talking about a lot of power each day that they're using. The state of Georgia's #1 economic driver is actually agriculture. And so a facility like Boehringer Ingelheim is very important to our economy in the Peach State. One of our top commodities is poultry. And so facilities like this one here are very important to our state because it keeps our economic engine going. I love working for Jackson EMC because the work that we do impacts everyone, from things like the vaccines that go into our pets and the food that we eat, but also to the schools that we attend, to the jobs that we do. Something as simple as picking up a telephone requires electricity. Turning on a television, you wouldn't be watching this right now if it wasn't for electricity.
And thanks to electricity, I'm able to host this fun show and answer your final quiz question. We asked, this electric item was first developed in the U.S. in 1891. Well, here's what you all said. Take a look at that. It might surprise you, but the correct answer is the electric vehicle. In fact, the other items weren't even developed until about 20 years later. Shocking, I know. Well, that's our show. Check out gpb.org/electricity for electrifying ideas and activities. I'm Ashley Mingwasser. We'll see you next time for another live exploration. And just to further prove the point of this program, lights out.